In 2018, astronomers witnessed something truly extraordinary, an explosion so sudden, so luminous, and so peculiar that it defied conventional understanding of how stars die. This event, known officially as a 2018 COW, but affectionately nicknamed the COW, became the prototype of a new class of cosmic explosions, luminous fast blue optical transients, or LFBOTs. And while these mysterious flares raise deep questions about the unknown mechanics of the universe, they also open up thrilling possibilities for discovery. At their core, these space explosions represent a scientific mystery, but not a menacing one. In fact, they might be among the most hopeful cosmic events we've encountered, offering a new lens into some of the universe's most elusive phenomena. To understand the optimism scientists feel about LFBOTs, it helps to consider how rare and surprising they are. Since the COW first dazzled telescopes over 200 million light-years away, roughly a dozen similar explosions have been found. Each one appears suddenly, becomes astonishingly bright, sometimes up to 100 times more luminous than a typical supernova, and then fades away within days. What sets them apart isn't just their fleeting nature, but their intensity and color. These bursts radiate with a striking blue hue, a sign of their extreme heat, around 40,000 degrees Celsius. This temperature alone places them among the hottest known transient events in the visible sky. Initially, the cause of these explosions was unknown. The first suspicion was that they were failed supernovae, stars that attempted to explode but instead collapsed inward, giving rise to black holes or neutron stars. But that theory is now being challenged by something even more compelling: that LFBOTs may mark the feeding frenzy of intermediate mass black holes, a long hypothesized but never conclusively observed class of black hole that fills the gap between stellar and supermassive black holes. If true, this would be a breakthrough discovery, a missing piece of the cosmic puzzle that has eluded astrophysicists for decades. That's where the real excitement begins. Confirming the existence of intermediate mass black holes would be a monumental stride in our understanding of the structure of the universe. These mid-sized black holes, thought to weigh between 100 and 100,000 times the mass of our Sun, could explain how the most massive black holes at galactic centers formed over cosmic time. Moreover, they may even hold clues about the nature of dark matter and the unseen scaffolding of the cosmos. And LFBOTs, if they are indeed created when these elusive black holes consume stars, could serve as beacons that reveal their locations. Each new LFBOT adds another piece to the growing mosaic. Events like the koala, the camel, the finch, and the wasp have followed the cow, each with its own distinct features, but similar in their rapid rise and blinding brightness. These flares are so captivating that they now prompt coordinated global efforts. Robotic telescopes scan the skies nightly to detect them, and when one is found, alerts ripple across networks of astronomers. It's a kind of astronomical flash mob. Scientists around the world turning their instruments toward a single spot in the sky in hopes of catching a glimpse before the event fades. In November 2024, one of the most promising LFBOTs yet was discovered at 2024 WPP, nicknamed the WASP. What made this event particularly significant was the timing. Scientists caught it right at the beginning of its flare, enabling instruments like the Hubble Space Telescope to capture early, detailed observations. Preliminary findings suggest this explosion lacked the expected material flow of a failed supernova, reinforcing the black hole consumption theory. And perhaps more strikingly, earlier analyses of the original COW event have revealed a flat disk of material consistent with a star being shredded by gravitational forces, providing further weight to the idea of a black hole at the heart of these events. Of course, not all scientists agree on the exact mechanism behind LFBOTs. Some propose that they might originate from rare, massive stars called Wolf-Rayet stars being consumed by smaller black holes. Others suggest variations on the supernova model. But the prevailing theory that these are evidence of intermediate mass black holes has captivated the scientific community for a reason. Not only does it fit the observational data, but it would also explain a gap in our understanding that has long been a thorn in the side of astrophysics. And there's more good news. The hunt for LFBOTs is about to gain an enormous boost. In 2026, the Israeli-built ultraviolet transient astronomy satellite, Ultrasat, is expected to launch, equipped with a massive field of view that will dramatically increase the chances of catching these rare events. With it, astronomers hope to gather data on dozens, perhaps even hundreds, of new LFBOTs. That would be a game changer, finally providing the sample size needed to test competing theories and perhaps, at last, prove the existence of these ghostly mid-sized black holes. These explosions are not just cosmic curiosities. They're natural experiments, unfolding across the universe, helping us unlock the laws that govern gravity, matter, and time. The rarity of LFBOTs only makes them more precious. Like cosmic fireworks, they remind us of how dynamic and strange our universe truly is. But unlike fireworks, their significance doesn't fade with their brightness. Each one is a chance to learn something new, to take a step closer to understanding our place in the cosmos. So while we may not yet fully comprehend the cause of these bizarre and beautiful flares, the mere fact that we are detecting them, studying them, and forming increasingly precise theories about them is a resounding success. It shows that our tools are getting better, our curiosity is still sharp, and our universe is still full of secrets waiting to be uncovered. The LFBOTs are a mystery, yes, but they are a profoundly hopeful one.